Today we're gonna look at lists. Unlike many programming languages, or can we put it this way? Each programming language has a way of defining, has a data structure of defining a set of objects. The most common one is array. I'm sure some of you have come across that terminology. But for Python, they use the terminology called list. Now, a list can be anything. It can be, for instance, this list of names or list of whatever. If you're talking about, let's say, a shopping cart or a shopping system, or where someone can, shop online and they can, the items they have selected, they're put in a common data structure. We can call it a list or an array or whatever name you might use. But for Python, we use the terminology list. Now, you have a list of names, for instance, and you want to print them. So it's straightforward that you can just use print names. What do we get? Wow, after running, you get the same list. So, but just like what we saw with strings, you can also play around with lists using some built-in functions, or you're also using some, simple indexing approaches. For example, if you want to access the first item in the list, you could specify using that approach. Now, the first item for this case, let me use index 0. What do we get? If we print index 0, we get Kemi. What if we use, index 1? And I'm sure you can remember with strings, if we say something is at index 0, that means it's the first character. But for this list, it's the first object in the list. For this case, here it's the first name, here's the second name. So this is this name is at index 0, this name is at index 1. So if we run, you can see it's typing Bobby. Or someone can do like what we used to do is with the strings, where we can just give a range from, let's say, index 0 or index 4 to somewhere else. So you could say, but remember, when you're dealing with lists, remember to use those brackets, the square brackets. So let me say, I want to get from index 2 up to the end. So if I run, I expect to get names from Sarah to all the way to the end, regardless of whatever names we do have there. Oh, and you can do the same trick we used to do with strings, where you can, specify, for instance, you don't specify the first index, but you specify the end index. Let's say, well, I just want to get the names from the beginning, let's say, to the third index. When we run that, you can see we're getting Kemi, Bobby, and Sarah, excluding any item that is, or any name that is above index 3. So you can play around in that way, but also you can also modify. You can modify an index. No, an item. Let me use that phrase. No, not an index. You can modify an item or the value of an item. You can modify the value of an item. How do we do that? Let's say you want to change the word Kemi, or the name Kemi. Now Kemi is at index 0. So you could say names at index 0, right? We want to change it to someone. Maybe there was a typo, and we want Kemi with this, right? Now let's print the names. We have modified. Now let's print the names. What do you get? Who can guess? I'm sure the changes will be reflected. You can see here there was Kemi with Y at the end, and now there's IE at the end. So you can play around the way we used to play around with strings, right? So that is a list. I will continue, but just do this minor exercise pause the video, try to write a program that finds the largest number in a list. So we have this list here. Now we want to get a program that finds the largest number. So pause the video for a few minutes and then come back to continue. All right, here's the solution. Now we want to get the largest number. So what do we do? We can say maximum, I think. Let me use the word max. Right? Now to get the largest number, you're not sure where it is, right? So what you do, the simplest way is to assume the number, the index 0, the first number in the list, the largest. And what you do is just loop through the list to compare if whatever number is larger than the one at the beginning. What I mean is you can have a for loop for a for number in numbers. I mean for any number in these numbers. Yeah. What do you do for a number or for an item in this list? I use number, so you can use for an item in these given numbers. Now let's do some manipulations here. We go check each number in that numbers. We compare. We do if, right? If that number, the number I'm talking about here, or if the number, if this number is greater or equal, or let me just not say equal, greater than the maximum. The maximum is the one at the index 0, right? What do? We return the max. So we say we set max equal to that particular number. That's the simplest way you can find it. And what it does here is we go to compare each of these numbers to the maximum, right? What we do, if we find this number, let's say 3 is bigger than maximum, for this case it's 3, which is not, then we don't do this. Then we go to the next, right? If this number, which is 6, if 6 is greater than max, for this case max is 3, then we set that max. So instead of having the first index here, we set to the index which is 1, and we set that is 6. It's 6. I mean, we set that max to 6, and then we compare the next one, and then it goes that way. And then what do we do at the end? We just print. We can print the max, which is the last obtained enough. After all the comparison, it will just check which one is the largest, which was now assigned here. And if you print that one, it can show you, we have a problem. And who can guess the problem? They're saying for not supported between instance of int and list. What is the problem here? Right? So we made a mistake. What does this mean here? We didn't say numbers. We didn't allocate the index 0. So that was a problem. So if you try and you can see the index, I mean the largest number is 22, right? So it is as simple as that. Now let's see another idea in the list, which is called the two-dimensional list, where you find the list has, like, it is nested within another list. For example, if you take an example of a matrix, let's say you have a matrix. Let me define it here. A matrix, which is, define it right here. A matrix of, let's say the first row is 1, 2, 3, right? And we put comma. The second row is, remember to put in the square brackets, let's say 4, 5, 6. And maybe we have another row, which is the fourth row, or the third row, and it starts from 7, 8 to 9. Right? This is a two-dimensional list. It doesn't have only just a single list of items, but there are several lists. So we call them, they are two-dimensional lists. And you find a lot of applications in machine learning where you have to work with matrix. For example, you're going to work with images or whatever, from agriculture or from whatever. Those images, the pixels, the way they're arranged in an image or in a picture, are in a matrix form. So you find a lot of, this is just a simplest example I've given you of matrix, but you find a row which has like, 1,000 pixels and the column likewise 1,000 or 2,000. So you have some ways to manipulate that such kind of pixels. And pixels, remember, just numbers, just values between 0 and 255. You come to learn about that whenever you're in the course. So what can we do with this? Let's try to print this, right? We wanted to print matrix. What do we get if we print matrix as matrix, the way it is defined in our equation, right? What do we get? It is printing like this, right? Now we wanna get this particular item in that matrix. So what do we do? Let me try something else. Let's try to print matrix, but at index 0. What do we get? Someone, I'm sure, can guess. At index 0. Remember when we were trying to get index 0 of this list, we got Kemi, right? And what about this case? Are we gonna get 1, 2, 3, or are we gonna get just 1? Or are we gonna get, I don't know. Something was wrong here. Sorry, I was supposed to put in brackets. Okay, so what do we get? If we run this, you see we are getting 1, 2, 3. So that means the whole of this is at index 0. Is treated the same way as Kemi, or and if you see, then Bobby is the second. For this case, this is the index 1, then this is the second index, and so forth. Now, what if I just want individual element? I don't want a full list again, right? So I can go ahead and say, well, I don't want this. What I want is the matrix at index 0, but I want index 0 means the first list, but I want first list, but I want the first item in the first list, right? So it sounds confusing, but it's not. So I want this, and what I'm gonna get is this one. No, sorry, it should be index 0 again. Yeah, if I want to get 1, right? Let me print and see what comes out. That's 1. That's better. So what if I want index 2? This is 0, this is 1, this is 2, right? In the first list of our matrix. But if I run this, I'm sure I'm gonna get 3. If this is confusing you, let me comment it out. If I run, I'm gonna get 3, which is correct. And what if I want to get this last element here? So to get this last element, which is 9, I'm going to say this is index 0. So this is index 1, this is index 2. So I'm going to change this to 2, right? I'm sure we're together. And then this is, index 0, index 1, index 2. So this is also index 2. So if I run that, I'm going to get 9, right? If I would have changed this one to 1, I would have gotten 8. That's better. Or if I had changed this to 0, I would have gotten 7. So I'm sure we are together, right? So that is a 2-dimensional list. Now, a list has a lot of methods. We've seen some of them. We've seen you can manipulate them as the same way as you're working with strings. Now, here is some of the list of the methods. If you are interested in more methods, then you can Google the list methods in Python. You're gonna get a lot of them. But the important ones are these. Of course, when you're working with whatever the data types, you may need to get more other methods. But for this case, let's have a look at appending, inserting. So you can append. I'm sure some of you knows what appending means. Adding a list adding an item at the end of the list. Inserting means you're putting somewhere else, you want to remove, that's specifically known, you want to clear, you want to delete everything, you want to pop. When popping means you're removing the last item in the list. For those who did data structures at some point, I'm sure you can remember these terminologies. We're not going to go into the details of data structures, but you can remember this popping, indexing. You're just checking the existence of an item in the list. You want to count, frequency of an item in the list. So if you want to check, for instance, let's say, well, how many times that a certain item appear in the list. So you can use count, and you can see the frequency. You want to sort, and mostly in ascending order. If you want to reverse the sorted list, you want to copy into another place. And let's just try to play around with them. Now let's assume you're given these numbers, right? And you want to append. And I said appending, you're adding an element at the end of the list. So let's say numbers dot append, and I'm appending a number, let's say 12, right? Let me see, what do you expect if I run it? You see it's like doing nothing, but in the background it has appended, it has added in the number. Now we can print this. Let's see, let's print the new numbers now and see what stays at. You see 12 is added at the end of my list. So we have appended a number. So appending is just, adding a number. Now let's see if we want to insert. So we say numbers dot, remember to start with the variable that you have defined, dot, what do you want to do? You wanna insert. And what do you insert? Right? Now, where exactly do you want to insert? Inserting is tricky, right? You want to insert at the beginning, you want to insert at somewhere, let me say, I want to insert at index 2, but what the number do I want to insert? Let me say 9, right? And let me print the numbers, the new numbers. Inserting 9 at position, at index 2. Wow, you see this was in index 0, index 1. Now at index 2, now there's 9. So it is as straight as that, right? You can also remove a number, or you can also remove a specific item, not a number in particular. So you can say numbers dot remove. What do I want to remove, right? Well, I want to remove a certain number. Let's say 7. What will be the output? 7 is in our list. So let me see, what do I get? After printing the numbers, I see there's no 7 in my list, right? So most of them are quite straight, and you can do what? You can pop. What does pop do? Numbers dot pop. Actually doesn't take anything. It is because we are trying to remove the last item in the list. So the last item will be removed. And now let's see what is the output. After popping a number, after removing the last element, you can see 12 is removed, right? It's just like deleted from the list. Okay. So and several other methods that you can play around. Indexing, you want to index a certain number. Let me see what is index. Numbers dot index, numbers dot index. Let me try this. What does it do? There's an error. It's not in the list. You see, we're trying to index a number that's not in our list. Well, let's try to get the index of what? Let's say 2. If we run that, we're getting 3. That is the index of number 2. Is that correct? Let's say this is index 0, 1, 2, 3. That's perfect. So you can play around with these other methods, copying, reverse. Let me try the reverse. Or let me try the sort, actually. Let me try the sorting. Now, numbers dot sort. and sort doesn't take anything, right? Let me print the numbers. What's the result? So you can see it's starting from 2, 3, 4, 5, 9. So I've sorted the list, right? So what is? You can also reverse. So let me try to reverse. After these numbers are sorted, I can reverse. So I can say numbers dot reverse. What do we get? And let me print the numbers. Print the numbers, which were sorted in ascending order. Now I want to get them in the descending order. Let me see what comes out. Wow. So that's perfect. So you can have, you can open your Google and search for list methods, and then you can try to exercise. There's a lot of other methods that are in the list. And these are very useful whenever you're working with lists. And I told you, you find a lot of lists with images which are in form of an array. So we can find them in 2-dimension, and you wanna manipulate in some sort, right? So there's a minor exercise here. We want to look for duplicates and remove them from our list. You see, there is 2, 2, 4, 6, 3, 4, 6, 1, right? So what do we do? You can pause the video and try it, but I will show you in a moment. So we wanna remove the duplicates in the list. So what we do is we wanna get the unique numbers, and then we want to create a list of unique numbers. So the duplicates one will be dropped. So you can define another variable and call it unique or uniques, right? We're not sure of what will be in there, so we just leave it as an empty list, right? Now, after having that empty list, now we go to loop in the given list. So for a number of an item in the numbers, what do we do, right? So if a number, which is, I'm talking about here, which can be 2, 2, if a number is not in, so you can say, just say not in. So we could have said if a number is in the uniques, but now we're talking about if it's not in here, right? We add it there. I don't know. The idea is quite simple, right? If number is sorry, we start with not. We wanna negate not in uniques, right? What do we do? Excuse me. I think my nose is quite itchy today. All right, if a number is not in uniques, so remember the not when I was talking about the logical and, logical or, and logical not. So now we are talking about if a number is not in here. So we take 2, right? We see if there is no 2 here. If it's not there, what do? We append it. So we use uniques dot append. As I said, appending means adding at the end of the list. Now here, there was nothing. So if we append, and what do we append? We are appending that particular number, which is not in this unique list. So we append a number, and that's it. So we are done. So after you're done, you can come out of that loop and print out the uniques. So you don't need to print them while you are inside. You print out the uniques, right? That's it. So it will just check for each number in here, right? For each number in here, it will do what? It will check if that such number is not in this list. For example, by starting, it will check 2. Is 2 in this list? Well, the list is still empty, right? So it is not there. It will append. It will add it 2, right? Again, it will come back to the beginning of the loop, which is 2. Is 2 in the uniques? Yes, there is 2, which was this one. So we don't do this. We don't append. For this case, we go next. Is 4 in the list? No, we append. So once you run that, there's a problem here. I'm writing in English. Excuse me. So that was a stupid mistake. So you can see we are getting 2, 4, 6, 3, and 1, right? So we are removing the duplicates in the list. You can also do what? You can sort them, right? Let me try to sort them. So I can say uniques, or let me just print straight. Print uniques dot sort, right? What will be the output? None. This is a problem. Uniques dot sort should have sorted. Should do this. I think the problem is, what are we sorting? Yes, sort. Something is. Let me put it this way. Print uniques dot sort, and now print uniques. Let me see what went wrong here. Why did it say? So it is sorting in an ascending order. You can also reverse the sorting to start with, 6, 4, and so forth. So you have removed the duplicates, right? Thank you. All right. Let's see another related concept to list, which is called the tuples. Tuples is exact. Well, yes, I should say is also a list. The only difference is like these lists cannot be modified. So there are situations in programming where you don't want users to modify some of the objects. So if you don't want to modify some of the objects in your list, you define them as tuples. So it's the same thing actually, but this one, because you don't modify it, you don't mute it, it's called immutable. And there are only quite limited number of methods. Here we had a lot of them you can append, and because you don't want to modify, means you are not allowed to append, you're not allowed to insert, you're not allowed to remove, you're not allowed to, pop, and so forth. So what you can do is, I think there are only a few methods like counting and indexing. That's it, getting index of a particular item. So you may just want to count. Excuse me. So you may just want to count, or you can print